Okay, hello everyone. Yeah, so today we're actually learning um Go. Hmm, I was trying to check something. Yeah. Okay, are we live yet? I think we should be live. Yes, we are live. Then oh, well, we are paid for Obsidian, but oh boy, I can't. It's expensive. I don't have that money. I know I have a lot. Which you? So what's that?
Language that's not compiled is going to be slower than Go because Go is a compiled language. Now, don't worry too much if you're not familiar with the terms compiled and interpreted. We'll talk about those in just a minute. For now, just understand that Go is much faster than these languages when it comes to executing programs. If we're doing computationally heavy work, Go is going to be much more performant than some of these other languages. Now, here on the other side, I've listed some compiled languages. So when it comes to
Hmm.
compilation speed, Go is actually much faster than these compiled languages when it comes to compiling the code. Now, again, we'll talk about compiling in a minute, but for now, just understand that you have to compile your code before you can run it when you're working with a compiled language. And so, by having a fast compilation speed, like more quickly on our code, we can deploy it more quickly. It's not as expensive to run tests to compile the program and deploy it to production. So this is actually a huge benefit that Go has. Now, I do want to point out that Go does not necessarily run faster, it does not necessarily have a faster execution speed than all of these
Hmm.
languages, but it does beat them handily when it comes to compiling.
It's no right. Yeah, let's go for this. Computer needs mention for I think for page thingy or something. It should be the name. Let's see. This is so okay. So by doing this, you have to call it. Wow, that's interesting. So, and yes, I know the problem to this FMT commuting. Okay. And then we got, first of all, package main, then thing after package main, FMT to format, but it's not really format, right? Is this is what my internet is very slow. So I'm going to open. By the way, it's better than nothing. So let's see. My power is slowly coming.
Compiled languages are faster than interpreted languages.
Let's
Interpreted languages
practice.
have better developer experience than compiled languages. This is some of the stuff that I'm hearing online. Let's actually break it down and talk about the difference between a compiled language and an interpreted language. When we write code, we write it in a human readable format, right? Typically in a file, in the case of Go, a .go file, right? Maybe main.go. And this file is going to contain human readable text, right? Go code that we as developers work on. The thing is, your computer's hardware doesn't know what any of that human readable text means. Your computer's CPU only understands binary, right? Which is ones and zeros, right? Which at the end of the day is just numbers, right? But it's just numbers and simple operations, things like add and subtract. So we need some process that we can use to convert human readable code to machine code that can be executed by the computer's hardware. And that's all that compilation is. Compilation is just the process of taking some human readable code, right? Go code in our instance, and converting it to binary or machine code that our computer can actually understand. So, what does this process actually look like? Well, normally you'd start by writing your Go program. So, say main.go, and you'd run it through the Go compiler. On your command line, you'd type go build, and that would produce a new file, which is the executable program. Let's say we were doing a hello world program. It might be hello world.exe,
EX.
right? An executable program on your computer. And then you could run that executable directly on your operating system without ever having to use the Go toolchain again. So the great thing is you can take this hello world.exe program and give it to someone else, and they can run it on their computer without ever having to install the Go toolchain or even know that you used Go to build the program in the first place. This is different than languages like Python, where if you want to run someone's Python code, you have to use the Python interpreter every single time, and you run the source code directly on your machine. It's also worth pointing out that part of the reason that compiling is so much faster at runtime is that we do all of this compiling work up front. So when we go to run the executable, we don't have to do any conversions from human readable text to binary machine code. That's different than how interpreted languages work. With an interpreted language, as we run the program, the interpreter is reading the human code and kind of at runtime converting it to machine code that the CPU can operate on. Not to beat a dead horse, but I want to talk a little bit more about execution speed. So we talked about how Go is generally faster than
Fast
the
in
interpreted
compiling.
languages, right? Python, JavaScript, Ruby, PHP, and so on. It gets a little interesting when we compare Go to kind of the natively compiled languages or the languages that compile directly to kind of machine code that runs on your CPU versus the compiled languages that run on top of a virtual machine. Right. So the two big ones that run on a virtual machine are Java and C Sharp, while some of the compiled or natively compiled languages that you'll be familiar with might be Rust, C, C++. Even though Go is a natively compiled language, a language that compiles directly to machine code like Rust, C, and C++, its execution speed is actually more similar to Java and C Sharp when it comes to its runtime speed, how many computations it can do kind of per second. And we'll talk more about this later, but the primary reason for that is the Go runtime. There's basically a chunk of code that's included in every Go program that manages memory, and that tends to slow down the execution speed a little bit. That said, it is worth pointing out that a Go program tends to use much less memory than Java and C Sharp because there isn't a need for an entire virtual machine.
Okay, so okay, I mean, this is easy. Let's see. To deploy or compile, more simple to deploy or compile server. Compile code is more efficient, but that's true. They are not running. They are not running on get. I think it's more efficient. Let me go with this. Oops, I failed. Is it compile code is faster? Then I was because they are not running time language dependence. It says go runtime, right? That's strange. More simple to deploy a compiled language compiled to deploy. Okay. Why did you more simple to deploy a compiled server? Oh yeah. It's actually true. Since it's just going to use a processor that's the CPU of the server, they don't really have to install kind of I think interpreter or something that does that at runtime. Right, I lost my script, so be it. Mhm. I don't know what we do. String what lane Java. Oh, since Java has like a virtual machine, which means even like it runs on a virtual machine. So, but let's read here. Wow, this is impressive. Oh my God.
Go, Java, and Rust all have very different approaches to how they manage memory, and that has huge implications for how the performance of their application play out. Let's talk about it. When we're talking about the performance speed, how fast it can do computations, right, which is kind of measured in CPU cycles, and then we also have memory consumption, which is just how bloaty the program is, how much data it has to store in memory to be able to do those computations. Every program you write, no matter the language, is going to be using memory. Every time you create a new variable, it allocates space in memory where it can store that variable's data. Now, in languages like Rust or C, memory management is effectively manual. Now, that said, Rust does have some nice tooling that kind of takes care of it for you at compile time, so it's not quite as error prone as it would be in C or C++. But at the end of the day, your program is allocating memory, right? It's saying this chunk of memory I'm going to use. I'm going to store some variable data here in this bit of RAM. And then later, your program says, I'm not using it anymore, so we can free it up for use by other programs. Now, let's jump over to Java. So with Java, it's a little bit different. Java is a garbage collected language, garbage collection, which essentially means that memory management is automated.
Okay.
And in Java, it's done by the Java virtual
Right.
machine. So every time you
JVM.
run a Java program, you're actually creating an entire mini virtual machine that your Java bytecode runs within. So this is the JVM. And then you kind of insert your code into the JVM and you run your code in there. And the JVM is what takes care of allocating and freeing all of the memory that you use. And this creates overhead. Basically, at the end of the day, Java programs use quite a bit more memory than Rust or C programs. Go is in an interesting sort of in between world where Go.
Okay, so let me take a guess. I might be wrong, but I think Go might actually, okay, half is given to the developer and then half the Go runtime does that by itself. But let's see.
Is a garbage collected language like Java, so it has automated memory management.
What does it mean? Yeah, it means to be garbage collector. Okay.
But it does not have a JVM. When you compile Go code, rather than having to run it within a JVM, just like with Rust and C, you get one binary or one executable program. The difference is that Go includes a runtime within every single binary that's built using the Go programming language. So we could think of it as something like this. It's kind of like a little sidecar that is compiled alongside your code. So your Go program basically has this little bit of extra code that's added to it, and that bit of code is what handles garbage collection and automated memory management. So it's a little more bloaty than what you'd get with Rust and C, right? It is garbage collected, but it's
Mm,
not nearly as expensive in terms of memory overhead as a language like Java or C Sharp.
yeah. To cook fried chicken. Yeah, this is the answer. Oops. Actually, I have a question that I would like to ask. I'll probably check it later, right? So, thing is, uh, question, um, garbage. Anyways, sorry guys, my spelling sucks, so I have to live with that. That's um, I that's and this like how it works. You doesn't it? Um, doesn't it look so like screen out new thing, you know, kind of like mini. Anyways, I'll ask that. So I'm actually in the boot.dev Discord. Okay, open your Discord is up. Hey, it's the best. I really like the Discord because they always kind if you have any question you get answered immediately. And he's always active. So see what to say. So let's go back. So over here. Basic types. Think he. So I think this should add test 2 bit and probably 64 bit. Yep. Okay, I think we actually yeah, I think he's going to explain it here. So we don't need to worry much about that for now. So let's see. Well, you know what? Actually, let's, what does this int? Okay, 8 bytes, 16 bytes, 2 bytes, 64 bit. Let's see, what does this unit does? Uint. Let's see. Actually, I have zero idea what is happening here. Zero idea. And what even this means. I have zero idea. Okay, let me go with the food there. So what's the assignment? I think so. Just submit, load. Okay, it has to be var. Well, it's still not formatting. Okay, float 64. Are you kidding me? I'm just going to test 2. Then var customer. And then image should be int. Then file, var, ones. Permission should be boolean. Or how is it written? This thing as bool. Or it's nice. It's nice to know. And then var username string. This is basic for English. Zero point zero France. I failed. Oh, it worked. I thought this was going to fail this. But finally it worked. Guys, I'm very tired with my head.